Okay, Assalamualaikum and good morning to all. So today is our first class on machine and mechanism design. So this week only we go online uh, formally. Next week we'll try to do both. So we're gonna go to the labs because lots of you are taking final year projects. So final year project students, you can stay inside the campus. Kalau student yang tak ada final year projects, you can go into the campus. If you have bad network quality or something, then you can ask and request from campus management to enter the campus since you don't have network access and such. So into introduction and some basics, kita still boleh go theoretical online lah. However, next week there'll be a lot of some practicals lah, and it's better for us to do face to face lah. And location kita dekat bawah lah, dekat dekat design lab, yang CAD design lab kat bawah tu kan. So we're gonna meet there lah next week onwards. So some basics on machine and mechanism design. So most likely we have to go to VLE first. So let's open up VLE. Log in to your VLE and go to your course. If you cannot find on your dashboard, cuba cari dekat future ataupun dekat past. And then go here lah to your VLE. Over here you can see a lot of notes lah, a lot of things that you can download and you can study. So kita punya course, we do not have finals lah for this course. Tapi since we have dual mode, I don't know yet lah how it's going to be. But from what I heard, bulan 10 semua orang dah boleh masuk lah. Sudah boleh masuk campus. So hopefully everything will be normal by October. But for the time being, yang ada dekat rumah and such, you can always visit the recording lah. So we have a lot of practicals lah. We have a lot of labs. Kita ada 5 lab. And then kita ada 2 projects. So total kita ada 7 lah. 7 assessment yang you do on your own lah. Other than that, you also have practical test. So practical test 1, 2 and 3. So everything is 10% each for practical test. Project slightly larger at 15%. And buku teks yang paling penting kamu guna adalah inilah. Ini, ada 2 buku lah. This first book, Machine and Mechanism by David Mizka, and also this one, Machine Element from Robert L. Mott. So you can read these 2 books lah. These 2 books is very important for us to start designing machines and mechanisms. So machines and mechanism is when we design things that move lah. We are going to analyze the motion and such and do some calculation. So ini PowerPoint yang kamu boleh download dan buka, introduction and also kinematics diagram. The rest kita belum buka lagi lah, kau tak confused banyak sangat. So let's go on to our first lecture. Before that, I think semua orang dengar kot, no? Network quality okay ke? Hopefully okay lah. Okay, so let's start. So machines. So these are some pictures of machines. They are simple ones lah. This is very simple. This is simple machines. So if you look at this machine, this is a sawing machine. Kita ada blade kat sini kan. This is a blade. We have a very rigid arm. So this rigid arm is powered by this crank. And also there will be some sort of axis here, pin joint. And then kita ada belting dekat sini. And then powered by this, another belting. This one to control something lah. But I think the main motor is at the back here. Ni motor. So this is some sort of like a simple mechanical machines. Next photo, this is slightly more complicated machine lah. This is maybe you know, this is a milling machine, CNC milling machines. And next one is very complicated machine. So this is a robotic arm. So this robotic arm, it has a lot of degrees of freedom lah. So ini dia boleh rotate kan. Ini one can rotate 1 degree of freedom. And then this one, this arm can rotate also another degree of freedom. And then over here also it can rotate another degrees of freedom. Kat sini dia boleh rotate arah ni, and then dia boleh rotate lagi arah ni. I think finally dia boleh rotate arah ni. So 1, 2, 3, 4, 5, 6. Maybe this robot is 6 degrees of freedom punya robot. So this robot is very complicated lah. So from rather simple to intermediate to very complicated robots, you can categorize all these as machines lah. So machines are devices that consist of fixed or moving parts. So it uses mechanical energy, and definitely that mechanical energy kita transmit jadi something more useful lah. So definitely semua machine ni ada task lah. It has certain tasks yang dia kena buat. So it can be cutting. Ini sawing, right? This is sawing. This one is milling. This one is to perform motion lah. Very complicated motion. So dekat hujung ni kita ada something called end effector. So end effector. So everything moves. So dalam kelas kita akan belajar lah how do we control all this motion. Okay, so next term of language yang kita kena belajar is something called mechanics of machines. So far kamu pernah belajar something called engineering mechanics kan? Engineering mechanics, I think you learn first year kot, first year, second year. So now we are learning mechanics also, but mechanics on motion of machines. So basically it is the science on or practical application on how you can design and do construction of machines and tools. So kita nak belajar science on motion of all these machines. What kind of machine we can see here? This is something slightly more simple lah. Ini ada macam gantry motion. Dia boleh gerak left to right. Can it move this way? Maybe it can. This one is some sort of assembly conveyor belt for transporting or inspection of electronic goods. This one I'm not sure what machine, but the power is being driven by belting and also some gears. So basically kita belajar inilah science behind machines. Definitely hold on. Inside our machine design, we need to use a lot of parts lah. So there will be a lot of parts and a lot of components yang kita kena guna untuk build kita punya machine lah. Some of these parts you can see in front here. You have bearing, apa lagi, belting, kita ada pulley. We have some here, slider punya rail. You've got some gears. Ini ada linkage. This is a connecting rod punya linkage. What else do we have? Some sort of brackets lah, all this. Yeah, fasteners, gears. So all these are components lah that you are going to use for building your machines. Other than that, you also need some sort of power transmission. So power transmission, you have got energy lah, right? You want to transfer all your mechanical energy to do some work. So most likely kita akan pakai some sort of motor lah. Motor. So motor is everybody knows it rotates. So it rotates just rotary motion. So daripada rotary motion ni kita nak convert. Maybe you want to make it move linearly. Kita nak bagi dia pergi left, pergi right, left, right. Tapi everything comes from this rotary motion. So kita kena pandai lah how to alter kita punya motor punya power tu kepada motion yang kita nak. Maybe kita nak motion dia bergerak daripada sini and then rotate like that. Maybe kita nak make sure dia rotate like this 90 degrees and then dia patah balik. So from point A to point B. Tapi still kita guna motor juga. Motor ni still rotate 360 degrees. Tapi kita punya end effector tu, kita punya linkage, dia bergerak from point A to point B 90 degrees sahaja. So how are you going to alter that? So all these things we will learn, and we will learn how to design them lah. So over here you can see this one very complicated lah. This is some sort of gearbox. So you have a lot of gears involved. This one untuk reduce lah. You want to reduce your speed. What is the ratio? And over here you can see this one is a chain car. This is a chain. This one is a timing belt. Timing belt. Yeah, this one is probably a timing chain. So these are all power transmission punya methods lah. So kalau kita look at a very proper system, ini adalah sketches ataupun drawing of a proper system. What we have here, kita ada grinder dengan drum. So power untuk operate this grinder and drum, kita punya power datang dari this one lah. This is our source, which is our motor lah. So motor, you guys know motors, right? You have 1 horsepower motor, you've got 2 horsepower motor, or maybe 3 horsepower motor. I think 1 horsepower, siapa ingat? Berapa watt? I think, yeah, online, right? You ask and then you answer on your own. 740 kot. Siapa tak tahu, boleh Google. I think 745 something. So kalau dia 1 horsepower, 740, 2 horsepower, 1.4 kilowatt, 3 horsepower, around 2.2 kilowatt lah. So, motor ni, kita ada, this one is, ini indication of bearing, right? Semua orang tahu kan? These are all bearings. Ini shafts. Kini kita ada bevel gear, dia tukar arah. Ini kita punya grinder lah. This is our grinder. Dia tengah grind something lah. Grind. And then other than grinding this thing, it also operates another gear here and then goes here. This is a gear and then this one is another gear. Definitely this is a shaft. Gear ke-8 lah ni. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dah ada 9 gear lah. So, of course lah, your gears will have some sort of teeth. Ataupun dia ada punya radius. Finally, dia operate this counterweights. Ini 50 kilo. Ini 200 kilo. Let's say acceleration dekat sini 2.5 meter per second squared. Let's say this requirement is given here. you need to select lah, nak pakai motor power berapa. 1 horsepower cukup ke, 2 horsepower cukup ke, 3 horsepower cukup. So something like this. Kita akan belajar dalam kelas lah, how to select motor power. Later on we will learn. Okay, next. Besides from power transmission and such, kita juga akan belajar something called kinematics. Semua follow ke? Semua okay lah? So, kinematics. Okay lah. Intro je kan? Tak ada calculation teruk-teruk lagi. So, kinematics is a study on how things move. So, dia belajar tentang geometry je lah. Geometry of the motion. So, kalau kinematics, kita tidak kira lagi force. There is no force. Tak kira force lagi. Kita just kira motion saja. So, benda apa yang kita berminat? We are interested in position. We are interested in displacement. Position kita pakai apa? Meter. Displacement pun meter juga kan. Kalau rotation, theta lah. Ataupun radian. Kalau speed, meter per second. Velocity, sama lah kan. Speed, velocity, acceleration, meter per second squared of the mechanism. So, maksudnya, kalau kita ada mechanism macam ni, kalau orang tu rotate ini, macam nak buat lah? Katalah angular velocity dia, omega lah kan. Omega berapa? Berapa speed dekat sini? This is some sort of pemotong kot. Pemotong kertas. Shearer. Pemotong kertas. Ini hand operated lah. So this blade will go down. So berapa speed of the blade? V dia berapa meter per second? So you don't know lah kan. This one depends on the input by the user. Tapi let's say this whole thing, let's say this shearer, kita buat some sort of practical test kan. Convert this shearer, soalan dia adalah convert this shearer to automated using motor. Tiba-tiba kamu nak tukar daripada grip yang pakai tangan orang ni kan. Ini ada pakai tangan orang. Tangan. No more tangan. Kita nak pakai motor. So motor tu kamu nak letak kat mana? So how do you redesign the whole thing using a motor but performing the same process lah. Performing the same function. So bila kita nak potong kan, kalau kertas, kalau tebal, force dia tinggi juga lah kan. Let's say kita nak potong aluminium plate, katalah 1.2 mm plate aluminium. Berapa force? So kamu kena redesign the whole thing and then pasang motor, and maybe you need to alter the linkage ni, how to alter and what to do. Itu kamu kena pandai-pandai lah. Kita belajar step by step. So soalan practical test lebih kurang macam ni lah. So kamu kena buat from zero until finish. I think it's about 3 hours. And then kamu kena submit lah kamu punya CAD tu. Submit pakai VLE. So far kita punya target of this course is for you guys to be competent in doing something like this. Kamu tengok problem, you can redesign, or you can just design, or you can reconfigure and modify and make it automated. Dan kamu boleh kira juga what is the power, what is the force required to do certain operations. So this is the objective lah of this course, so that you guys will have the knowledge and know-how and tak takut lah kalau jumpa benda-benda macam ni. So you guys are capable to tackle these kinds of problems. This one is another lift. Ini something called table lift, scissor lift. We'll see this again later on in next slide. So, kenapa kita belajar kinematics? Contoh, kinematics analysis yang kita buat, it's going to impact kita punya design. Why? Let's say kamu nak kena design benda ni kan. This is a scissor, SCISSOR, scissor lift mechanism. So this scissor lift mechanism, if you look properly, you have how many? Ada satu, ini dua, ini tiga, ini empat. So you have 4 actuators. So this 4 actuator is probably hydraulic lah. 4 actuator hydraulic. So you guys have learned pneumatics and hydraulics before, right, in the class. So you know how hydraulics work. But in our class, let's say kita punya scissor lift ni kita guna untuk angkat a car. This is a car. So your car weighs about 2 ton. So 2 tons. So kalau kereta kamu 2 ton, kamu nak kena bagi pressure dekat sini berapa? What kind of force are you talking about here? Ini force. So kalau ada 4, berapa force kena apply dekat sini? Let's say kamu design change, kamu tak nak pakai 4, kamu nak pakai 2 saja. So piston ni, hydraulic punya actuator ni nak kena letak dekat mana kan? Where is more efficient? There's gotta be some place yang dia jadi efficient and some place dia tak jadi efficient. Why do we say this? Let's say katalah saya buka white screen. Let's say you have a door, right? This is a door. Mana pintu dia ada angsel kan? This is a, what do you say, hinge. Hinge. This is the knob of the door. So if you want to open the door, normally you will apply a force from this side lah, dekat knob. Apply force. Kalau buka dekat knob ni, so if you look from the top, this is the door, this is the knob, this is your hinge. So you give a force like this. This is the force. So kalau lah force kamu bagi 100 Newton, pintu kamu ni lebar dia katalah 0, tak makan besar kan, 1 meter, pintu lebar 1 meter, 3 kaki, 100 Newton, 1 meter. So you are giving it a moment. Berapa moment dia? Moment sama dengan force kali distance. 100 kali 1. Jadilah 100 Newton meter. This is your moment lah. 100 Newton meter, you can open the door. However, kalau kamu buka pintu, kamu buka ke sini. Kamu apply ke sini. And this distance is very short. 10 cm. This distance is very short. So force kamu, definitely kamu tak boleh pakai 100 Newton lah. In order to open the same door, kamu kena bagi dia lebih kurang 1000 Newton. So 10x. You need 10x more force to open the same door if you don't open it properly. So same thing goes for design. Kalau kamu tak design properly, Kamu kena bagi banyak force, kena buat banyak energy. Motor tak perlu 1 horsepower, kamu kena buat sampai 3 horsepower. So that's why you have to design efficiently. So this is our target and our task, how to design things efficiently. So same goes dekat benda ni lah. There are many places that you can put this actuator. Apparently he chooses to put it here lah. So you can experiment this out, computationally pun boleh buat, manually pun boleh kira. So a lot of design questions. So benda ni nama dia adalah design questions. So what is the significance of the length of the legs that support the platform? Length of the legs. Kamu nak buat leg dia macam tu ke? Or you want to make it longer? Macam tu. How do you decide? You don't know. You have to learn lah this subject in order to decide. So is it necessary for the support legs to cross to be connected at the midspan? Or is it better to arrange that so that they're closer to the platform? Midspan ataupun closer dekat platform. Dia nak buat midspan macam ni ke? Ini cross midspan lah. Ataupun dia nak buat macam ni. Macam tu. Ini midspan tengah-tengah. Ataupun kat sini. So how far must the cylinder extend to raise the platform 10 cm? Yeah, this one is the plunger punya stroke lah. S-T-R-O-K-E. Berapa dia kena extend? Kalau kamu beli hydraulic cylinder kan, hydraulic cylinder, what do they look like? Hydraulic cylinders. So dia ada dia punya extension dia, plunger rod. Berapa paling jauh dia boleh bergerak? So dia boleh extend up to this length aja lah. Katalah kamu beli, dia boleh extend. Dia kata, how far must the cylinder extend in order to raise the platform 10 cm? Yeah, from original length kat sini, dia naik atas 10 cm. 10 cm. Plunger ni pula nak kena extend berapa? So, sangat susah lah nak calculate manually. But you can do that also. You can choose graphically ataupun you can use your computer lah later on. You can learn berapa benda ni kena extend untuk dia bergerak naik atas. So we'll plot a lot of graphs lah. So yeah, we will learn this one later on. So there are a lot of questions that you can answer in order to design this thing properly lah. Banyak lagi kah? So kinetics, you've learned this before. Kinetics, you learn in engineering mechanics. Ini benda kamu kena kira tentang all these things lah. Force, moments and torques. So yeah, we will involve all lah. We will learn also kinematics dulu. Kinetics ni kita belajar sikit. Cuma sekarang dulu kamu kira manual kan. Benda-benda macam ni dulu kamu kira manual. Hand lah. Hand calculation lah kan. The thing is, now you can simulate. You can simulate all this. For example, something like this. Yes, you can simulate. A problem like this, you can simulate also. Simulate. I think you guys have learned finite element analysis dulu kan, FEA kan. So FEA susah lah nak simulation benda ni. If you use motion analysis, dia tak perlu buat meshing apa, tak perlu. But you have to give proper input jugalah. Some sort of like a drawing a proper free body diagram jugalah. Something like this, kamu boleh apply load 300 Newton. Boleh check what happened to this omega. Ataupun if you have a problem like this, ini adalah some sort of pendulum. So pendulum ni ada benda-benda yang berat kan. This is a very berat thing. This has rotary inertia ataupun moment inertia. Kalau siapa tak ingat so benda Allah ni dia ada rotary inertia atau moment inertia. When you raise it up at certain angles from here, for example, kamu raise dia 45 degrees, berapa dia punya speed masa dia impact dekat bawah specimen tu kan? Velocity ni berapa? Other than doing your own calculation, you can input the whole design. Design benda Allah ni kan, berat berapa, what kind of material you use. You can simulate the whole thing. And we're gonna get all those dynamics punya graph lah. For example, displacement here, displacement, force. You're gonna get all the dynamic inputs lah. And we can also input time. Yeah, you can get time punya output domain dia. Force analysis boleh jadi susah ataupun boleh jadi sangat senang. So some sort like this akan jadi sangat susah lah. Some sort of like this, kalau kamu nak buat stress analysis, katalah nak buat stress analysis kan, stress, kamu bolehlah pakai FEA, finite element analysis. You can fire up your abacus and you can do a lot of stress analysis. Tapi kalau kamu nak buat force, it is much easier to do motion analysis. Contoh kalau benda Allah ni berapa? Dia nak carry 500 kilo. So 500 kilo is here lah. And your center of gravity, this one is 500 kilogram. So 500 kilo here, you can already identify berapa force dekat sini. Ini, force. Force, F-O-R-C-E, force. So what kind of hydraulic cylinder nak kena pilih kat sini? What kind of hydraulic power you need to put? So of course hydraulic power comes from your hydraulic fluid. So hydraulic fluid dia ada dia punya compressor dia. So what kind of pressure you're talking about? So things get much faster and easier lah kalau kita pakai motion analysis lah. Because if you go to FEA, you need to discretize all the elements, kena buat a lot of connections, kena buat boundary condition yang very hard, and sometimes the result is not very good also. So now we are not leaving our design space. You are still in your design mode. You are still using your SolidWorks. You can do modifications some more easily. Kalau if you see that this location is not good, let's say this location is not good, now kita boleh tukar dia. Kamu boleh tukar, I want to put here lah. Let's say I want to link here. So instead of our original position here, you want to put here. So you can do this easily guna SolidWorks saja. Kalau kamu nak go back and forth pakai abacus kan, it's going to be a nightmare and it's going to take 3 weeks. Padahal benda ni boleh settle dalam maybe 3 days, this kind of analysis. So that's why industry is now making this tool very easy for engineers lah to use. You don't have to convert all your data to abacus and such. You can immediately use your SolidWorks. Apa lagi something like this. So benda Allah macam ni pun boleh kira jugalah. You can study and check the stability. Ini apa? Ini crane. Crane ada berat. This thing weighs 5 megagram. So ini adalah 5 tons. So kita ada ni outriggers. Ini dia extend keluar. Is this enough? Rasanya benda alam macam ni dia ada counterweight tau. Kalau kamu tengok crane-crane kan, dia ada benda berat. Kadang-kadang dia pakai konkrit punya batu tau. If you see at construction site dia ada counterweight. So counterweight ni will help dia punya lifting punya weight lah. Apa soalannya? Outriggers A and B are used to stabilize, avoid overturning, determine the maximum boom angle. Oh ni. So dia nak kira ni lah. Theta ni paling maksimum berapa? Berapa? Maksudnya kalau dia naik atas, ini okay, no problem. Sini. Kalau dia jauh lah. Kalau jauh dia lagi, kan, kata dia jauh kat sini, dia punya weight dia lagi teruk lah. So moment dia akan jadi terbalik. So dia nak kira berapa ni lah. Theta ni berapa maximum? What is the maximum theta? So that this crane does not topple over lah, tak terbalik. Banyak lagi noh. So we've got a lot of applications. This is, lebih kurang macam kita belajar tadi lah. Scissor lift. Tapi definitely this one got people upset lah. Ini duduk atas ni. Apa dia buat? Cuci sawang kot. Ataupun ganti lampu dekat MPH tu kan. Our multipurpose hall tu is very high, ada lampu. You need some sort of like this lah, even to change the lamps. And something like this has to be designed properly. So macam mana lah kan, hampa nak kira berapa, siapa perasan binatang ni macam mana? How does it work? Definitely some sort of hydraulic cylinder lah kan. So how high can this go up? How high? So kalau manually calculate, it can take a lot of times lah. But you can use computer to analyze berapa tinggi dia boleh pergi. Katalah design specs 10 meter high. So kalau 10 meter, kamu nak pakai berapa jenis berapa set? This is 1, this is 2, this is 3, 4, 5. Ini 6 level kan? 1, 2, 3, 4, 5, 6. Ada 6 level. So kalau customer nak 10 meter, nak design macam mana? Customer kata no, not enough. We want 15 meter. So kamu tak perlu redesign the whole thing, just tambah aja lah. But then, kamu kena decide lah. What is this one lah? This dimension. What is your main scissor dimension? To do all this. Macam-macam lah kan. This one, I think this one is some sort of puncher. Punch. Ataupun metal stamping kot saya ingat ni. I think this one is metal stamping. Metal stamper. So you ada some sort of crank. This one goes up and down lah. Stamping on metals. Ini dekat kita punya workshop pun ada. But you don't see it lah. It is mounted dekat roof tu. Ini kita call something like a gantry crane. So we have this. So how it is being designed, I think this one is critical lah. Dia pakai dia punya chain mechanism, all this. And then dia boleh gerak pula kan, left and right. Dia boleh gerak left and right. Other applications, if you're looking at small robots, macam benda lah kaki ni kan, this leg. This is the leg of a robot. How do you design this leg? How many degrees of freedom? Kalau leg macam ni, kena pakai berapa motor? 1 ke 2? So, you will learn lah later on. Actuator dia macam mana. This one is slightly different. This one ada macam clamp. This is a clamp. This one, ini dia pakai track. So this sort of rubber track untuk, I think, very low profile punya application lah. I don't know, rescue mission kot, maybe. This one, another example of a mechanism that you can learn and you can learn how to calculate. Ini adalah some sort of pipeline punya inspection robot. So kalau kamu ada a lot of pipes, so your pipes can get very very far, can get very very long. Very very long. Very long pipe. Maybe your pipe is for water, or maybe your pipe is for gas line. So in order to inspect, contohnya ada blockage, ada some sort of blockage, ataupun ada crack dekat pipeline. So how to do that? You cannot put people inside this pipeline, right? So maybe some sort of a machine like this, some sort of like a contraption. Apa yang pelik kat sini adalah dia punya roller ni, dia boleh adjust according to diameter. Ini kan, ini dia ada pin joint, lepas tu dia ada linkage. Here is another pin joint, lepas tu ada linkage. So this is another linkage. So bila design macam ni, ini spring loaded, spring. So dia boleh guna untuk variable diameter punya pipe size lah. Maybe this one large, maybe this one is a small one. So dia boleh masuk. Ini kabel lah, maybe this one kena ada kamera lah. Kamera mount dekat sini. And then kamu just masukkan dia ataupun tarik je lah. Tarik dia and then you can inspect properly your pipeline. So the thing here is, how do you design this mechanism yang boleh dapat variable diameter. Diameter dia berlainan. Diameter. This one more complicated lah. This one is a windshield punya mechanism. Kalau siapa perasan, if you go to your motor car, dekat depan ada windshield punya wiper. So wiper tu dia akan operated by a single motor. Ini adalah motor. So daripada single motor tu dia boleh rotate very funnily ya. Dia pergi sini, lepas tu dia patah balik. Dia pergi sini, lepas tu dia patah balik. So if you look here, siapa perasan? If you look properly ya, ini susah nak design. Tengok ni. Ini dia punya coverage dia untuk wiper 1. Ini wiper 1. So benda Allah ni berapa angle dia? 90, maybe 100 35 kah? Ya. 135 degrees. Tapi wiper number 2, coverage dia macam ni je. Sini sampai sini. So this one is roughly only 90 degrees. Ya, so wiper design pun susah. So this is your main wiper. This is your main wiper. So if you are the lead designer to do this, kamu dapat soalan dia macam mana? Dia bagi cermin kat kamu. So dia bagi cermin. Macam ni kah cermin? Something like this. This is the cermin, and then they want coverage like this, and then they want another coverage like this. Ting ting ting. Ni. Ini je dia punya design requirement dia. And then you have to design the whole thing lah, the whole mechanism. Ataupun nak pelik sikit, I think dulu punya Honda Civic kan. Honda Civic dulu ke? Ataupun sekarang, I'm not sure. I think dia wipe satu macam ni, satu pun dia wipe macam ni. Some sort of pelik punya wiper mechanism. Dia tak pergi left right macam kereta biasa. Ini dia pergi same motion kan. Ini dia pergi opposite direction. So benda Allah ni pun dia pakai one motor only. So very hard for you to design this. Lepas tu pula berapa RPM kat sini? RPM. Berapa nak letak kat sini? Kalau RPM tinggi sangat, katalah kamu letak 100 RPM. Maybe the wiper speed berapa? Kan? Kan wiper speed ada speed kan? Speed 1, speed 2, speed 3, speed 4. 5 pun kadang-kadang ada. Tak mungkin lah. Tak adalah 3 je kot no. 1, 2, 3 kot. Low, medium, high. I think 3 speed kot. So 3 speed ni kamu nak configure dia macam mana? You want to tell your electrical engineer speed 1 100 RPM. Speed 2 berapa pula kan? Maybe 120. You don't know. You have to simulate all this motion inside the computer supaya you get what is the design requirement lah. Maybe this one, I don't know, 170 RPM. So there are a lot of design questions here. And the things that you need to decide is all this length. Ini ni. Banyak panjang pada Allah ni kan. Ini. Ini kan motor. Ini panjang berapa? Ini panjang berapa? Ini. Separated ni berapa? Ini. 30mm dia letak ni. Kamulah kena decide sendiri. So what happened? So machine design and mechanism design can be complicated or it can be simple also. Depends on the designer himself lah. This is an example of how it operates. So kalau kamu tengok betul-betul kan, saya boleh lukis juga. Boleh juga lah. Even though it moves, dia punya speed dia tidak linear. Dia ada slow sikit. Bila dia nak sampai tu jadi slow. Dia tak macam tung 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 tung. I think original masa zaman 50-an kot. 50-an. Dia orang design wiper macam ni. Ting 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 ting. So dia jadi pening. This is a true story. Orang pening bila tengok wiper design yang cepat macam tu. So engineers think about it and they do a slow motion like this. So this one is some sort of like a ergonomics punya knowledge jugalah untuk driver tu. Tak annoying untuk dia tengok masa driving waktu hujan lah. Okay, so that is for introduction. You want to keep the ink? Discard. So as an introduction, this is the thing lah. So, of course there's no question lah. Ada question ke? Any questions you want to ask me? So, I think we have another half an hour good. So, as an introduction, that is the part lah. Why do we learn machine design and also mechanism design? So, of course lah, you guys do not need a break You guys are already in break. So, next lecture. That's the thing, online class. So next lecture is something called, never mind, we do this quietly. Next one is something called kinematics diagram. Kita ada sedikit lagi knowledge yang kita kena belajar. Lepas tu minggu depan kita boleh buat some sort of labs lah. So kinematics diagram. Ini kita dah tengok tadi. I have explained to you why we have to learn this. Sekarang ni kita kena buat something called kinematics diagram. So if you guys are in electrical engineering kan, kalau electrical dia belajar all this circuit diagram kan, capacitors, resistors, power source dia buat macam mana? I don't know. But the thing is, they learn circuit diagram. CIR kot. CIRCUIT. Circuit diagram. DIAG. Circuit diagram. But you guys are mechanical engineers and you guys are mechanical design engineers. You have to learn something called kinematics diagram. So kinematics diagram ni adalah how do you visualize the motion. Mesin yang kompleks kan, macam wiper tadi, very complex. Kamu nak design dia tak boleh design macam tu. Kamu kena design pakai lidi je. Lidi ni connect macam ni. Original design dia pakai lidi macam ni je. Lepas tu sambung macam tu. Lepas tu ada linkage lagi. So people design it from a very simple punya diagram. So this diagram is called kinematics diagram. So we use this to simplify things supaya kita punya analysis tu tak susah bila nak tengok. So segala parts kita tukar dia jadi skin ataupun skeleton, tulang je, one sort of rod. So dimension yang penting je kita letak. And motion, what kind of motion yang dia buat, we have to show them lah. Benda yang penting adalah kita kena lukis scale dia proportional dengan actual. Kalau benda ni patutnya ini kecil, ini besar, so you draw it proportionally lah. So jangan draw dia macam tu dengan macam tu. Ini dah tak proportion lah. Macam ni kecil besar, okey lah betul. Ini kecil besar sama tak boleh. So you draw it in proportion to the actual thing. Links kita letak dia sebagai 1, 2, 3. Links. Joints kita letak dia sebagai A, B, C, D. Kalau kamu belajar dulu kan free body diagram, kalau kamu ingat lah kan, dulu belajar structure analysis lah, ingat lagi. If you ada structure macam ni kan, katalah ada structure macam ni, dekat semua tempat ni kamu ada joints kan. All these joints ni kamu tak nama dia 1, 2, 3 kan, kamu nama dia sebagai A, B, C, D. Kata ada force kat sini kan, kamu letak ni sebagai F, C. Kata ni E kalau ada force kat sini, kamu letak dia sebagai F, E, right? So joints kita bubuh letters A, B, C, D. Kita punya link pula kita bubuh numbers. So ini link 1, 2, 3, 4, 5, 6, 7. So that is our naming convention lah untuk kinematics punya diagram ni. So daripada benda yang kompleks macam ni, ini kita panggil dia simple link. Daripada macam ni kita lukis dia satu lidi je, one lidi, and hujung dia kita bagi dia terang, bagi dia titik macam tu. So hujung ni kita adalah dia punya joint. This is the joint. So if you want to name this one, hujung ni nama A, hujung ni nama B. Benda Allah ni nama dia 1. It's like that lah. We draw it simple. This one is some sort of a crank. Dia ada bengkok sikit kan. Bengkok macam ni kan. Ya, bengkok macam ni. Kita lukis dia simple je. One line. Since dia ada shape sikit kan, kamu boleh buat macam ni lah. Buat macam tu. But still lah, sini A juga, sini B. Naming dia boleh juga nama 1 ataupun 2 lah, depends. So if you look here, this is joint. This is joint. So tempat yang ada join, kita kena letak dia punya tu alphabet A, B, C, D. So next, benda Allah ni you have 3 joins. Sini satu, ini A, ini B, ini C. So hujung ni join, hujung ni join, hujung ni pun ada join. So this one is A, this one is B, this one is C. You have to give it a name lah. Maybe ini link number 4. Letaklah 4. Ini link number 2. So it's like that. So these are called primary joins. Okay kan? Senang kan? Should be okay lah. So benda tu adalah simple. So next, we see some sort of pin join. If you have 2 links, ini dengan sini. So it's like this lah. Ini nama dia katalah A, ini link 1, ini link number 2 lah. This is something called pin join. Pin join yang paling basic lah. Next is something called slider join. So slider ni, kalau if you have a block macam ni, block macam ni yang kamu dah mill dia punya slot kan. This is a slot. You have this slot. So since you have this slot, this thing will move back and forth. Dia pergi kiri, pergi kanan. Something like this, kita lukis macam ni je. Satu line, lepas tu lukis rectangle. So if you draw something like this is a slider join. Slider. So it goes left and right. Tak perlu lukis terus macam ni. Just draw this slider. Again, this is still called primary joins. So next will be something called more complex one. Ini adalah cam joint. So this is a cam. Maybe some of you have seen a cam in action. Dia ada cam, dia ada something called a follower. Kalau lah siapa ingat lah. This is a cam, is a follower. This is a gear joint. So you have a gear and sometimes you have a pinion. Kadang-kadang you have a driver. So these two are gears lah. Gear tak payah lukis gigi-gigi apa tak payah. Just lukis bulat ni je. This is a gear. So you draw it simple. However, cam joint dengan gear joint ni dia masuk kategori higher order joints. Okay. Itu je lah nak kena telan. I think ini je. Ada lebih tak? Tak ada lebih. Most of these are simplified as this lah. Now you come to the main thing. So now you've come to the main calculation. Bukan calculation lah, drawing point. So, tengok balik benda ni. This is something called a shearer tadi kan? Shearer. Macam mana kamu nak convert benda Allah ni? Convert dia menggunakan all this linkage which you are using for your kinematic diagrams. So there are a few steps lah. There are basically 4 steps. Number 1, kita kena cari dia punya base. Base ni adalah benda yang tidak bergerak. Not moving. Not moving. Ataupun fixed. So fixed or not moving, this is the frame or the base. So frames typically kita akan letak sebagai 1. So 1 means it is fixed. Ataupun yang paling main lah. So all other motion kita determine dia relative to the frame. So benda yang paling main sekali adalah benda yang tidak bergerak. So cuba tengok balik ke sini. Semua benda bergerak. Betul tak? Linkage ni bergerak. Dia punya mata pisau ni bergerak. Kita punya link untuk tangan ni, kan ada tangan orang kat sini kan, dia bergerak juga. So benda tak bergerak ada 2 lah kan. 1 kat sini, Satu lagi kat sini. However, this is a better choice lah. This one. So this one we'll take it as a base. So dia jadi dia punya main. So this is the base. Lepas tu you have to identify all the other links. Links kita number dia sebagai 2, 3, 4 lah. Yang ni dah first kan. Ini kita punya frame. And then kita identify dia punya joints. Joint kita letak A, B, C, D. Kadang-kadang you have some sort of point of interest. Point of interest kita boleh letak sebagai X. Contoh point of interest. Katalah kamu nak study hujung ni. So hujung ni jadi point of interest lah. Kamu boleh letak hujung ni sebagai X. Ataupun kamu nak study kat sini, tangan orang. Tangan orang kita boleh letak sebagai Y ke. So that's the thing you have to do lah. So in order to do something like this, let's start. Number 1, identify the base of the frame. So base dia jadi macam ni lah. Ini adalah pin joint. Benda Allah ni nama dia 1. Nak buat bulat ke? Buat bulat lah. 1. Lepas tu ada link. Link dia bentuk macam ni sikit. Kamu nak buat satu line macam ni pun boleh lah. No problem. Lepas tu dia ada another link here. Lepas tu another link here. Lepas tu kita ada, ingat lagi ni, kalau slider lukis macam ni je. This is a slider. Slider lukis kotak dengan line. Simple thing. Lukis kotak dengan line. Macam ni je. Benda Allah ni walaupun nampak kompleks kat atas ni kan, dia punya motion dia macam ni je. Ada lagi kah yang pelik? Boleh tak nak lukis benda ni jadi macam ni? Boleh je. Just draw it as close to the original one lah kan. So bila kamu draw macam ni, kamu tahu benda apa yang penting. So dimension yang penting. Ni, this one. This dimension is important. Can I use a different color? Pen color biru. Ni. This one, berapa kita letak? L1 ataupun dimension X lah. L1 lah. L1. Lepas tu ini dimension yang critical. L2. Apa lagi dimension yang critical? This one. This one pun critical juga. And then this one to the handle, maybe L3. So daripada benda yang susah macam ni kan, susah nak tengok ni. It's very hard to visualize things. You can change to something slightly more simple lah. Tadi lebih simple lah, saya lukis LL ni jadi payah boleh lah. I'll remove all this L. Jadi senang boleh lah. So if you look at this, it is much easier to visualize. So the thing is, kamu kena ni lah, identify all the links. Ini fix base dia, letak 1. Lepas tu another link ni boleh buat nama dia sebagai 2 kah? Ini nama dia 3. Lepas tu slider nama dia 4. Ini nama dia A kah boleh? Ini B lah. Ini C. C ni sebab dia ada pin joint kat sini kan. Ini D. D sebab ada slider. Betul ke? Jadi something like this lah. So benda yang penting adalah we call this something called, we are trying to deconstruct. S-T-R-U-C-T. Deconstruct ni kita bukan construction kan. Construction is you building. Deconstruct is you simplify. So you are deconstructing this machine into very simple links. So benda ni baru kamu boleh faham. So this is how you do kinematics diagram. Other than that, there is something called mobility ataupun degrees of freedom. So mobility, actually mobility ni senang je. Mobility ni adalah berapa, ini yang paling senang sekali. Berapa actuator yang diperlukan untuk control the motion. But mobility ataupun degrees of freedom, this is the original definition lah. Berapa independent input yang diperlukan untuk precisely position all the mechanism. So contoh macam kita punya alat ni kan, this alat, kita nak control dia, berapa input kita perlu? You only need one lah for this one. Ini naik atas, ini turun bawah. Satu input ni dah properly boleh define dah benda Allah ni. So this one, the mobility is equal to 1 lah. You only need one input. So kalau benda ni kamu nak convert jadi automated, boleh pakai satu motor je. So one can control every motion. Kamu boleh define precisely. Contohnya kamu nak shearer ni naik atas ni. You want it to go up by 5 cm. So you can control only one thing lah. So only 1 degrees of freedom. So you can calculate mobility by using some sort of this guy's equation lah. His name is Grubler. So you can use Grubler's equation. So Grubler's punya equation ni boleh decide if you have a very complicated mechanism, berapa dia punya degrees of freedom. Meaning, berapa actuator, berapa motor yang diperlukan untuk completely control dia punya motion. Kadang-kadang boleh jadi 1, kadang-kadang boleh jadi 2, kadang-kadang boleh jadi 0. Kalau 0 tu dia akan jadi locked. Lock mechanism. So this is some of the example lah. Contoh for single degrees of freedom. Kalau kamu letak motor kat sini kan, letak motor kat sini, kamu suruh dia putar 45 degrees. Kamu memang total control. You don't need 2 motor to control benda Allah ni. You only need 1 input. You can precisely control. Ini mesti akan berubah in some location and it will be fixed. So this one is more mobility is equal to 1 lah. This one mobility is equal to 0 because it is locked. You put motor pun tak jadi apa kan. This one dia punya degrees of freedom ataupun mobility dia jadi 2. So kalau kamu ada motor satu kat sini pun, kamu tak boleh completely control. Ini dia boleh bergerak lagi. Dia boleh bergerak sana, dia boleh bergerak sini. So kamu perlukan 2 input. So in order to calculate this one, we can use this formula, which is 3n tolak 1 minus 2jp minus 2jh. N stands for linkage. Ingat tak linkage dia? Linkage adalah 1, 2, 3, 4. Linkage. JP adalah primary joints, iaitu spin dengan sliding joint. JP. So JP ni joints. Kan kamu ada A, B, C, D. These are joints lah. Tolak pula higher order. Higher order ni adalah untuk cam dan gear. So kalau ada gear joint, kita dia punya perkali dia 1 je lah. Ini 2 kali. So this one is how you use mobility punya equation using Grubler's. But the main thing is kamu nak decide berapa actuator yang diperlukan in order to control that motion. Sekarang. Now is the time for you guys to do this one lah. Leaf table. I know you guys can open up this you don't semua orang ada kertas kan, so now you can draw lah. Draw the kinematics diagram untuk benda Allah ni. So no need to, don't look at the answer yet. Semua orang lukis sendiri. How to draw this one into proper kinematics diagram. Kinematics ni maksudnya dia jadi tu je, linkage. Ni untuk simple. Kalau yang kompleks kamu boleh buat macam tu ke, kompleks, ikut kamu lah. Complex. Now convert. So how do you do this? Remember, first step is this one lah. Mula-mula cari dia punya base, ataupun benda yang tidak bergerak, ataupun fixed, not moving. Kat sini apa benda yang tidak bergerak? Can you identify your base? Boleh dah lukis, everybody? So this is definitely the base. So something like this. Kita akan base kita punya drawing all to this one lah. Bengkok pula. Macam ni. So this is the base. This is 1. Semuanya will be relative to this one lah. This is your base. And now you can draw your linkage lah. Buat satu line macam ni je. One line. And then this is another join. Tengah ni pun ada join kan. So this tengah ada join. This one is like that. Lepas tu macam mana? Ini ada apa kat sini? What kind of linkage there? This is definitely not a pin joint. This is some sort of like a slider. Betul tak? Sebab dia ada motion dekat slot ni kan?
Dia slide.
So kamu kena convert ni sebagai slider. Lepas tu macam mana lagi nak buat lah? Bawah ni motion
Slider
dia
ke?
ya. Bawah ni pun slider juga. Slider. Lepas tu ini tergantung-gantung. Ini dengan ni macam mana?
Atas tu fix kan, belah kanan.
Atas ni fix. Fix ni maksudnya tak bergerak langsung tau. Kalau kamu simen ke sini, ini fix lah. Tapi kamu tak simen. Dia ni boleh masih bergerak turun bawah, naik atas kan. So macam ni memang bolted kan. Ni fix. Macam ni dia ada macam link juga ni. Cuba korang tengok ni. Ni link. Cuma link ni dia sambung dengan base ni. So dia lebih kurang macam mana? Lebih kurang macam ni lah basically. Tapi dia ada free play dekat sini lah. Ini ada, dia boleh gerak. Sini dia boleh gerak. So bila draw kinematics diagram kan, it's good idea bila kamu draw kinematics diagram ni, kamu untuk kefahaman kamu sendiri, ini lukis dia punya ni, free play dia macam mana. Ini lukis kiri kanan. Ini pun lukis kiri kanan. This is good for your information lah. And then you can label lah. Ini 1. Ini link nama dia 2. Ini link dia nama 3. Ini link nama 4. Ini slider 5. Ini slider juga 6. Lepas tu bukan, alfabet. A, ini B, C, D, E. So lebih kurang macam tu lah. So daripada very complex punya machine ni, sebelum orang lukis macam ni kan, sebelum orang design macam ni, orang lukis ni je. Orang panggil apa ni ah? Ini apa? Orang lidi kan? Ni orang panggil orang lidi kan? Orang panggil apa? Something like this lah. Kamu sebelum design benda Allah ni, before you go complex, you do simple. Kamu kena decide dulu. Length ni berapa? Length ni berapa? Based on kamu punya machine punya requirement. Bila benda ni dah decide, baru kamu go complex. So never design machines terus jump to complex things macam ni. Kamu kena lukis dia pakai line-line macam ni dulu. So use your pen and paper. Then later on we learn graphical tools lah, yang pakai komputer punya, how to do these calculations. So kinematics diagram. Mobility ni pun boleh kira jugalah. You can look here, how do they calculate mobility. End up kita dapat mobility dia as 1. So kita cuma perlu one actuator. Macam ni dia pakai screw ni tak? Dia pakai some sort of lead screw. So lead screw ni boleh control the whole motion. Kamu boleh tahu dia at what height pakai satu lead screw. So you only need one actuator to control precisely motion dia kat mana. So ini degrees of freedom dia adalah 1 lah. Next. Semua orang try. This is your grip punya vice tu. Vice grip ni kamu pegang dekat tangan kan. Dan you don't know where is your fixed point. But then you still have to select lah. Benda apa yang paling main sekali? Benda apa yang fixed? Dan dia adalah main reference. Which one? Mana kamu nak select sebagai frame? Anybody have any idea? Adakah yang bawah ni dia bergerak-gerak, ataupun this part, ataupun dia punya gigi bawah ni, lower jaw or your upper jaw? Lower jaw. Mana satu? Macam mana nak lukis ni How do I clear the screen think erase all ink on the slide. Erase all ink. So jawapan dia adalah kita ambil yang ni lah. Ambil atas. This is your fixed. Walaupun dia tak fix, kita anggap dia fix. Kalau tidak, susah nak analyze. So macam mana nak lukis? Kita boleh lukis dia macam ni like that. This is a pin joint. Ini pun ada pin joint juga kan? This one is another pin joint. Ini pun fix juga. Kalau kamu nak link macam ni, tak ada masalah, kamu boleh link supaya kamu tak pening. So like this. And then kita ada ini link kan. Ini buat satu line macam ni je lah. Link. This link. And then ada link macam ni. Bengkok pula. Link macam tu. Lepas tu link macam tu. Betul ya? Kalau kamu nak control tangan orang tu, Hujung ni kan, kamu boleh letak dia sebagai X. Maksudnya dia adalah point yang kamu berminat lah. Lepas tu macam mana? Ini nak buat macam mana? Macam tu lah. Macam tu. Ini letak dia sebagai Y ke? Macam mana? Betul ni? Kau salah. So benda Allah yang susah ni nak faham ni. Buat link macam ni. Ini link dia. Of course ini nama dia one lah. Ini frame, ini base, ini nama dia one. Ini nama dia one. Ini nama dia two. Ini nama dia two. Ini yang tadi lah, ini nama dia three. Lepas tu and then this one link to here, and then this one link to here. 3. Ini nama dia 4. This whole thing is a 4. There you go. Macam tu lah. So before kamu design benda Allah ni, before you design this, kamu kena tahu dulu berapa dimension ni. Ni this dimension. This dimension berapa, nak tahu. Opening dekat sini ke sini berapa. This dimension you have to know. Ini upper jaw upper jaw macam tu. You don't care. Kan ini tempat grip tu kan. Ini tak bergerak lah. Ini adalah fixed. Yang Y point ni je yang bergerak. So bila X kita trigger, kita grip, kita tarik naik atas, Y akan grip. Even though this thing is very simple lah. Sebab design ni ini design dah lama kan. Orang lain copy je design ni. But if you were to do this from the beginning it's become very hard lah. This vice grip ni. Some more kita boleh control pakai ini pula screw ni kan. This screw will control apa screw ni. Control this distance susah ni. Dia akan control this distance. Dia akan pergi depan sikit ke ataupun belakang sikit. Which controls this opening kan. This one. This one is very complex. Kita lukis dia bagi simple. Ni. This is our kinematics diagram. Inilah kinematics diagram. Ini je yang kita belajar hari ni, kinematics diagram. Ini pun susah. But this one is a lot of places are using this one already. This one semua orang buat sendiri. I'm gonna wait 1 minute for you guys to draw on your own. Semua orang ada kertas kan? Take out your paper and pen. Tell me where is the frame. Frame mana? Ataupun dia punya base, which is fixed. Yang fixed tu kat mana? Adakah nak pakai atas ni?
Base kat bawah.
Ya, senang kan. So, lukislah. Cuba lukis. Everybody, don't look at the answer. Cuba lukis tengok. Pin join. And then convert dia jadi diagram yang paling simple sekali. Settle kah? Semua orang okey? Obviously, lukis pin join. Nak lukis dua ke pin join? Lukis dua je lah kan. Yang penting kamu yang faham, bukan orang lain faham. Kamu dah sampai level belajar untuk kerja. Bukan belajar untuk exam lah ni. Kamu belajar supaya kamu senang nak faham. We learn important things lah. Nak lukis macam ni pun boleh. Ataupun nak lukis 2 point macam ni pun boleh. Ikut kamu lah. Janji kamu faham. So, linkage. Ada satu link ke sini. Macam tu lah. Satu link sini. Satu link. Lepas tu link ni pergi sini. Macam tu. Lepas tu link ni dia join je ni. Walaupun dia join macam ni, dia ada pula tempat tekan kan, toggle tu kan. Kamu nak masukkan boleh lah juga buat macam ni. Sebenarnya tempat orang tekan tu kan. So, lepas tu macam mana? Maybe macam tu ke? Tapi kamu nak control ni kan, this point. Okay lah, setakat mana yang kamu faham. Ini tempat control clamping point tu kan. This is the clamping point. This one we call point of interest. Point of interest. In this case, kat sini kita boleh nama dia X, ini boleh nama dia Y. Y macam ni. Sini X, sini Y. X sebab apa? Clamping point. So, dimension yang penting, this one lah. Ini berapa? Ini dimension berapa? Ini dimension berapa? Tapi dia punya main dia kan. Main motion dia ni je lah. Ini je. Link ni kepada sini, kepada sini, kepada sini. Inilah main dia. This is the main thing. Yang define the whole mechanism. So as long as you understand. Many ways you can draw. Okay, I think we have a few more code. This one, let's try. This one is a can crusher. I think you get the hang of it lah. Tengok pun dah tahu kan. Yang paling penting, of course, I think you have established. Ini adalah part number 1, which is your frame. So, lukis lah. Lukis slider. Slider macam tu. And then kita ada linkage. Kepada situ. Lepas tu, sini ada... sini ada slider lah kan. Sini ada pin join. Ini sambung. Macam tu je pun. Slider. Ada 2 link. Ada 3 pin join. Ini adalah A. Ini B. Ini C. Ini adalah 1. Ini adalah 2. Slider is actually 3 lah. Oh, okay. This one patut 1 kan. Numbering. Ini 1. 1, 2, 3. Something like that lah. So, once kamu dah deconstruct this motion, you can design properly lah. Next is some sort of gear. Ini boleh tengok lah. Ini shear press. Ini tempat ni, nampak ni. Ini tempat dia letak apa dia? Rod. And then dia potong kan. Ini gigi dia. Ini adalah shear press. This one gets more complicated lah. Ini adalah landing gear untuk kapal terbang. So now you know lah how to deconstruct. It comes like that. Linkage. Another linkage here. Another linkage here. This one is a pin joint. Apa lagi lah? Itu je lah. Ini kita punya point of interest lah. X. This one is another pin joint. Am I missing anything? Ini gerak-gerak macam ni. Ini gerak macam ni. Ini gerak macam ni. Yeah. It's a good idea if you want to label something like this. This one rotary. Yeah, it's like that lah. Senang je lah kinematics diagram. Convert into something that you know. This one is a wiper. Wiper mechanism. Kan dah tak susah kan? Ini satu link, ini satu ini macam link tu lah. It become like this one is another one lah. So this one is a kinematics diagram of a wiper. So again, like what we have explained just now, sebelum design benalah ni, kena start with this one. Draw this first. Then you draw this one. Then you design something complex like this, okay? Now this is the motion of the windshield wiper. This one slightly more complicated. Ini adalah outrigger. Dia boleh letak foot. Ini kan. Ini ada piston. So again, pin joint dekat atas, pin joint dekat bawah. Lepas tu ini dia punya kaki. Ini adalah sliding motion. Okay. This one, some more lah. You can try. Okay, try this one last. Senang kot no. Too easy ah. Ini link. Tak payah try lah ni, senang sangat. Ini link. Habis. Ada a lot of links. This one rotate. Yeah, okay. Now, any mechanism now, you should not look at it and be afraid lah. Sekarang ni, kamu tengok apa-apa mechanism or machine or design, kamu check dia punya linkage macam mana. Ini satu link kepada sini. Ini satu link. Tapi dalam ni ada slider lah. Ni, slider. And then, this one is another linkage. Comes to another linkage. Dia pakai satu motor je. Ini benda apa? Ini adalah wear test fixture. So contohnya kamu nak test wear dekat sini kan. Maybe kamu ada some sort of fabric. Kamu nak test dia wear 1000 kali, 1000x. So is there any wear to the fabric or maybe some sort of coating? So this is the tester lah that you can see at the factory. Dia kena test kan. And finally this one lah. Ini draw. So today's attendance, kamu kena, cara dia adalah senang je. Ambil kertas kamu, sketch and then ambil gambar, lepas tu upload to VLE. Upload kat mana? Upload kat sini. Kalau buka VLE pun ada. You can go to VLE and upload. So today's attendance is this one lah. So just ambil paper, kertas, and then draw however you know, and then submit at VLE. So as a proof that you know lah what we have been talking about for 1.5 hours dah, 1.5 jam lah. Okay. So kalau tak langsung tak tahu apa, tulis tak tahu and then submit juga. Okay, there's no marks for this. Ini just attendance lah. But try your best lah kan. We have learned. So now you shouldn't be afraid of any mechanisms anymore. Do you want to keep? Discard. Where to upload? Of course, go to your VLE. Pergi sini lah. Ini attendance week 1 ni. Click here. And then submit. Okay. Habis cerita. That's all for this week. Is there anything yet, any concern on what we are learning ataupun anything in general?